Hi guys, welcome back to Pipro vs YouTube channel where curiosity meets the code. Today we'll be studying regarding data pre-processing. So the contents will include introduction to data pre-processing, steps in data pre-processing, goals of data pre-processing, common pre-processing techniques, tools and libraries, code example for data pre-processing and best practices, and lastly we'll be discussing regarding emerging trends in data pre-processing. Moving on, we have to know what is data pre-processing. Data pre-processing refers to a crucial initial step of cleaning, transforming, and formatting raw data to make it suitable for analysis and modeling in data science and machine learning. It's like preparing ingredients before cooking. If your ingredients are messy and inconsistent, your final dish won't turn out well. Then why is data pre-processing so important? Imagine analyzing data full of missing values, typos, inconsistencies, and irrelevant information. Your results would be skewed, unreliable, and misleading. Just like you wouldn't trust a recipe using rotten vegetables, you can't trust models built on your messy data. So what are the steps in data pre-processing? Firstly, data collection and exploration, identifying and gathering the data sources. This could involve internal databases, web scraping, surveys, APIs, or external data sets. Explore the data, use visualization tools like histograms, scatter plots, and descriptive statistics to understand data distribution. Identify missing values, outliers, and potential inconsistencies. Secondly, we have data cleaning, which we have learned in the previous video. Please do go there and check to learn a perfect in-depth knowledge regarding data cleaning. So what it includes, it handles missing values, decide whether to impute missing values, delete rows or column with missing values, or incorporate them into your analysis based on your specific situation. Correct inconsistencies, standardize the formatting, units, data types, fix typos, remove duplicates, and address any inconsistency in data representation. Outlier detection and handling, identify outliers that deviate significantly from the expected patterns and decide whether to remove them, adjust them, or investigate their cause further. Moving, we have data integration, combine the data from multiple sources. This often involves mapping and merging data sets while ensuring compatibility and resolving schema differences. And address challenge, account for potential issues like missing value, inconsistencies, and differing granularities across the data sets. Fourthly, we should do data transformation. Feature scaling and normalization transfer features to a common scale for consistent analysis and improved model performance. This may involve techniques like min-max scaling, that's called standardization. Feature in engineering, which includes creating new features based on existing ones to potentially improve model accuracy and capture relevant information. This might involve feature extraction, dimensionalization, reduction, and domain-specific transformation. And lastly, we have data discretion, convert continuous features into categorical variable for use with certain algorithm or analysis techniques. Fifthly, we have data reduction, dimensionality reduction for high dimensionality data techniques like principal component analysis, which is PCA, or feature selection, can be used to reduce the number of variables without significant informative loss. Data sampling, if the dataset is large, consider taking a respective sample to improve the processing efficiency and analysis time while limiting computational resources. So what are the goals of pre-processing? Firstly, we have to improve the data quantity, removing the missing values, errors and outliers, correcting inconsistent formats and typos, handling duplicated and reboundaries. Secondly, we have enhancing data consistency, standardizing the values units across features, scaling numerical features to similar ranges, and encoding categorical features for numerical calculation. Thirdly, we have optimizing data for analysis. Firstly, selecting relevant features that contribute to the model, reduce dimensionality to specify analysis and improve efficiency, and also transforming data into formats suitable for specific algorithms. So what are the common pre-processing techniques? Firstly, it includes data cleaning. Again, I've already made an in-depth video regarding data cleaning. Please do go and watch it there for in-depth knowledge. So basically it handles missing value, identify and correcting errors and outliers, handling inconsistency and standardization. And later we have data transformation, normalize and scaling, example min-max scaling, standardization. Thirdly, we have feature engineering, creating new features from existing data, discretion and binding, converting continuous variables into categorical. And thirdly, we have data reduction, feature selection, choosing the most relevant features, dimensionality reduction, reducing feature space uses techniques like PCA. So what are the tools and libraries used for data pre-processing? So firstly, we have common Python libraries for data pre-processing, which is pandas, numpys, scikit. So pandas for data manipulation and cleaning, numpy for numerical operation and array manipulation, scikit-learn for feature scaling, normalization and feature selection. Consider mentioning R libraries like DPLR and TDIR for cleaning and transformation. So for R coding, we use these two libraries as main libraries. So this is code example for data pre-processing. Firstly, we have to import the necessary libraries. So here I have imported pandas and numpy. And secondly, we have to load the data, which is df is equal to pd.read cvs your dataset.cv. And thirdly, we explore the visualize the data shown. So here we have df.describe or dv.his.dv for dv.plot. So we understand it by giving a more visualized format and identifying the issues in that. Later we have handle missing values. So this you can also go through. We have identified the number of null values and replaced it with mean for column 1, and we are dropping the subsets for column 2. Correct inconsistency. So here you can see for column 4, 6, 5, 6, 7 we have different approaches. So first one in column 4 we are replacing it with the lower one, and for column 5 the comma is replaced with nothing so that the comma is out of the screen. And then we have for column 6 we have replaced A, B, C, C, which is an error, which we want ABC is a categorical value. We have replaced it back to ABC. And then we have to standardize the unit is the 7th method, that is into 100 or into whatever means you have to convert it. 6th one is to detect and handle the outliers. So as usual, we have to have a Z-score and identify the outliers and replace it with a lower clip and an upper clip. This is what we have done for column 8. 7th one is feature scaling and normalization. So scalar is equal to, we are calling a function called standard scalar, and we have for column 9 and 10 we are fitting the transformer, so it is standardized for column 9 and 10. 8th one is feature engineering. So you can see df new feature is equal to column 4 plus column 5. Here a new feature is added by adding two columns together into one column. And we have data splitting also. So as we add it, we can split also. The next thing to do is split the entire data set into training and testing data so that we get the accuracy in the learner. So usually we train the data for 80% of the data, or maximum of the data is given for training, and for testing a less amount is taken, and we can compare and see the accuracies or F1 score or even other means of knowing that the model is performing good. So what are the best practices for data pre-processing? We have explore visual methods for understanding data quality and cleaning needs, emphasize the importance of understanding domain knowledge in data context, and we have considered the impact of pre-processing choices and downstream analysis and modeling, and later we have handling pre-processing steps in predictable and documented manner. So what are the emerging trends in data pre-processing? Firstly, we have explainable AI for data pre-processing. So as we all know, explainable AI is the most trending part as of now. We have to demystifying transformation, that is a traditional data pre-processing methods can be black boxes, making it difficult to understand how they impact model performance. Explainable AI, which is XAI techniques, are emerging to shed light on these transformations, providing insights into ways specific features are scaled, encoded, and dropped, building trust and enabling human oversights. And later we are having addressing biases and fairness. We have XAI can help uncover potential biases introduced during data preprocessing, ensuring fairness and mitigating discrimination outcomes in models trained and preprocessed data. Second is privacy preserving techniques. Different privacy. This technique adds controlled noises to dataset while preserving statistical properties, allowing data analysis without revealing individual information. This is particularly crucial for processing sensitive data while complying with privacy regulation. Federated learning, this decentralized approach trains models on multiple devices without sharing the raw data itself. This enables collaborative analysis while keeping the data secure on individual devices. Thirdly, we have active learning and human in the loop data preprocessing. Interactive feedback loops, the approaches continuously involve human experts in the data preprocessing process. Machine learning algorithm identify the potential issue or suggest the transformation and humans validate or refine them, leading to more efficient and accurate data representation. Domain knowledge and integration, leveraging the expertise of the domain specializes through the pre-processing pipeline ensures the transformation and the meaningful and relevant to the specific analysis goals. So this is it for data pre-processing. If you want some other topic to be discussed, please let me know down in the comment section below. And if you have learned something from this video, please do like, share and subscribe to our channel. Thank you.